Welcome to Scholar Opportunity Nexus, and in today's series of video, we'll be looking at addition of vectors or addition of inclined vectors. In our previous video, I made mention of a question where I asked, what if a vector is moving due north and a vector is moving due east? How would you be able to sum those two vectors up? So in this video, we are coming to look at some examples of vectors that are inclined at an angle other than 0 degrees. So in that case, taking this north, south, east, and west. So a vector A moving due north 5 meters per second and body B moving due east 6. Okay, let me make this 6 meters per second and 8. And body B moving at 8 meters per second. So taking these two bodies to find their sum or the added form of these two bodies, you see that they are inclined at an angle of 90 degrees. Since they are inclined at an angle of 90 degrees, they can form a right angled triangle. So let's bring this shape out. So this is 6, this is 8. Degrees. So the hypotenuse will now be what? The sum of these two vectors that are inclined, because I said one is moving due north and one is moving due east. So you see that they are inclined at an angle of what? 90 degrees. They will be inclined at an angle of 90 degrees, making this, let's give it a VR. So this is the resultant vector by adding it. So you know that in adding these two vectors by Pythagoras Theorem, V would be equal to square root of V will be equal to square root of 6 squared plus 8 squared, which so we get V to be equal to 36 plus 64. That will be square root of 100. Then meters per second. So for a vector quantity like this, two vectors that are inclined at an angle of 90 degrees, we are going to use Pythagoras theorem to solve or to get the resultant form or the resultant vector when adding these two vectors. Let's take another example. So yes, taking another example, two bodies. Let's say body A is moving due south, so body A is moving due body A moving due south. We have different form of vector quantities, but in this video I'm just using velocity as a very common type of a vector quantity. So it's moving due south at 3 meters per second, and body B is moving due west at 4 meters per second. So then they ask, what is the let me just say sum. We can say resultant or sum. But since we are saying addition, let me just use what is the sum of these two vectors. Question took a lot of space, but yeah. So we are coming to find what the sum of these two vectors. Body A is moving due south at 3 meters per second, and body B due west at 4 meters per second. So now we can actually just use the Pythagoras. The first we can use the cardinal point of view to just see the angle between these two vectors. So this is due south, this is south, this is north, east, west. So this is moving at 3 meters per second, and this is moving due west at 4 meters per second. So we see that they are also inclined at an angle of 90 degrees. So let's draw that. Let's bring it out. 90 degrees, meaning their hypotenuse will be where? Here. It's still a right angle triangle because both legs are inclined at an angle of what? 90 degrees. So in that case, we can still use our Pythagoras theorem to get this VR. And in doing that, we see that VR will be equal to square root of 16 plus 9, which is equal to what? Square root of 25, giving you 5 meters per second. So our resultant vector, or the sum of these two vectors, is what? 5 meters per second. So when solving or getting to understand the addition of vectors where these two vectors are, let's say, inclined at an angle other than 0 degrees, that's these two angles are not parallel angles, we have different form of finding them. And one is this, especially when they have what, or especially when they are inclined at an angle of 90 degrees. Basically, or mainly, we are going to use the Pythagoras theorem to solve this. So let's, in case or a scenario where these two angles are not inclined at an angle of 90 degrees, an angle other than 90 degrees, how would you solve them? We'll look at that in our next video. Thank you so much for watching this video, and I hope to see you in our other videos.